All right, this is a pretty exciting lesson because we are going to start proofs for the very first time. So good news is we're going to start off with something you guys probably already know how to do, which is solve equations. We're going to do algebraic proofs. So a proof is exactly what it sounds like. It's proving that something is true every step of the way. So here's the key to proofs. And this is what some of you guys are going to find kind of difficult, especially being honors kids. Being an honors kid, I think a lot of you, not all of you, but a lot of you guys like to do things in your head because you're pretty good at math. You want to skip steps. You can't do that. A proof, if you're proving something to someone, you can't just assume that they know. You have to show them every little step and how to get there. So proofs, let's put show every step with an explanation. If I'm proving something to someone, I'm not just going to tell them how it is. I'm going to tell them why. That's how you write a proof. So in order to have that explanation, we are going to have to know some properties, mainly the properties of equality. So most of these you should be familiar with. The first four are your basic operations, okay? The addition property of equality. Anytime you see property of equality, that means you're doing something to both sides. So if A equals B, then A plus C equals B plus C. Notice they added something to both sides. In math, that's allowed. Whatever you do to one side, you have to do to the other. Okay, so if you add something to both sides, that's addition property of equality. Subtraction property of equality works the same way. If you subtract something from both sides, that works. Or you can multiply something to both sides, or you can divide something on both sides. That's what all four of those are saying. All right, distributive property. Honestly, if you guys just want to underline distributive property, that's fine. Technically, the whole name for this property is distributive property of multiplication over addition or over subtraction. You could just use distributive property. So distributive property is used whenever you have that set of parentheses. So we've talked about this recently. 5a times quantity b plus c. This would be distributive property over addition. So you take a times b and a times c. This would be distributive property over subtraction. ab minus ac. All right, substitution. So when I substitute something, that means I'm taking something out to put something else in. Kind of like in sports, if you have a sub, one player goes out, one player goes in. So this property says if A equals B, then B can be substituted for A, or A could be substituted for B, either way. So if you take something out and plug something else in, substitution. Reflexive property of equality. This one, I just want you to star. We're going to use this one later. Reflexive property, we use a lot in geometry, not so much algebra. But it says for any real number, A equals A. Anything is equal to itself. X equals X. 2 equals 2, so on. We'll use that later, not necessarily right now. Symmetric property, this one we will use. Think about the word symmetric. If something's symmetrical, that means it's the same on both sides. It says if A equals B, then B equals A. So you know how sometimes you're solving an equation and you end up with something where you have like 5 equals X. You have your X on the right side instead of the left side. That's the same thing as saying X equals 5. So if you ever want to flip something around like that, that's symmetric property. And then we have transitive property, which again, this one we're going to use later on. But transitive property, I think of it like transporting. If you're transporting something in a car, think about starting at one location. If A equals B and B equals C, then A equals C. So like if you start at A and A goes to B and then B goes to C, then obviously A has to go to C as well. It's like A takes you to B, B takes you to C, therefore A takes you to C. Transitive property. We'll use that a lot later on, not quite yet though. So that's why I had you star those two. Everything else we're going to use today. I will give you another heads up. Should have set it up here. This substitution one is often used when we combine like terms. Okay, add that to where it says substitution. So here's how algebraic proofs work. In any 2-column proof, you are going to have a statements column and a reasons column. A statements column is where you kind of make your claim. The reasons column is where you justify your answer. Okay, so it says complete the following algebraic proofs using the reasons above. If a step requires simplification by combining like terms, you can write simplify or substitution. I've seen both. Both of them would be correct. You can do simplify or substitution. Okay. So in a proof, you're always going to have a given statement. The given statement is like your starting point. So step 1 in any proof that you will ever write all year long, you're just going to have your given statement. And for the reason, you would literally just put given. So we are given that 3x plus 12 equals 8x minus 18. Now this one, the statements are already filled for us. So we are going to work our way through and prove that x equals 6. You have to go step by step. You cannot skip anything. So from step 1 to step 2, they now have 12 equals 5x minus 18. So the question is, what did they do from step 1 to step 2? What happened? Well, I see this 3x disappeared and my 8x became 5x. So what did they do? They had to have subtracted that 3x out. So since they subtracted from both sides, that would be subtraction. Property of equality. I'm going to put POE for property of equality, just to save us some space. So from 1 to 2, they used subtraction. That's how we came up with 2. Now, look at step 3. Where are they getting 30 equals 5x? What did they do to get there? Well, I see that this negative 18 disappeared. What did they do to get rid of that negative 18? If you were solving this equation, you would have had to add 18 to both sides. So right here in step 3, to get this, they used the addition property of equality by adding 18 to both sides. And then from step 3 to step 4, they have 6 equals x. So what did they do to get rid of that 5? They divided. So division, property of equality for that one. Now from here, most of you guys would just say, okay, we're done. We proved that x equals 6. Almost. Notice the proof statement says x equals 6, but you have 6 equals x. You want it to match exactly. This is what I was meaning by proofs do not skip steps. We don't assume that our reader knows everything. We have to tell them every step of the way. So now we can say, okay, since 6 equals x, then x equals 6 by the symmetric property. If you look up at your chart, symmetric property of equality, I'm just going to put symmetric property. allows you to switch things around on each side of the equation, okay? So if A equals B, then B equals A. You can flip it around. So there's our proof. So we're going to do one more on the back. I want you to flip it over. Your paper is going to be blank. So we're going to write this down. Just take a second. Copy down given. 3x plus 4 equals 7x plus 8 minus 2x. We're going to prove that x equals 2. And then I want you to draw a statements and reasons column. If you need more time, just pause it. Statements, reasons. This is how all of our proofs are going to be set up this year. Okay, step 1 of any proof ever, every single time you go to write a proof, you're going to think, what's my starting point? My starting point is my given statement. What did they give me to start with? I'm going to copy this down. Step 1 is the given statement. You have to start somewhere. So the reason is given. Now we're going to prove to our reader that x equals 2, and we're going to justify each step by giving them a reason. Tell them why. All right, now sometimes the order of the steps doesn't really matter. Like I'm looking at this, and there's 2 things that I could technically do first. One thing I could do is go ahead and do my distributive property. Or if you look at the right-hand side of the equation, I could also go ahead and combine my like terms. I can do either one of them first. It doesn't really matter, but I do have to do them in 2 separate steps. In a proof, you have to break everything down 1 step at a time. So let's just do the distributive property first. Okay, so if I distribute this, I have 3 times x, and then I'm also going to have 3 times 4, which is 12. It's tempting to go ahead and combine another step and combine my like terms, but we have to wait. So we have to give a reason for each little step. So this one I just use distributive property. And it's only a property of equality if you're doing it to both sides of the equation. We did not change both sides. It's just distributed. Now let's combine those like terms on the right-hand side. If you're like me, I always like to get that out of the way. It bothers me. So my 7x and my negative 2x becomes 5x plus 8. And please listen to this. Technically, we did subtract the 2x. However, this is not, and I repeat, not subtraction property of equality, because we didn't subtract anything from both sides of the equation. We kind of just simplified it. So this is where you could put 2 different things, and I see it both ways. Depends on who's doing the proof. You could either put simplify, or you could put substitution. And if you're confused by why it would be substitution, it's kind of like you're taking the 5x and you're substituting it for 7x minus 2x, because it's the same thing. All right, now let's start solving. 2 things you can do here. I want to get my variable to one side first. That's just what I like to do. You could either subtract 3x from both sides and have x on the right, or I could subtract 5x from both sides and have x on the left. It really doesn't matter, okay? As long as you use symmetric property if your x is on the right. Since my proof statement has x on the left, maybe I'll just make it easy on myself and I'll move x to the left. So if I subtract 5x from both sides, I would have negative 2x plus 12 equals 8. So I subtracted from both sides. So subtraction, property of equality. I put POE for short. Okay, number 5. What would you do from here? I would subtract the 12 from both sides now. It's okay to use the same step twice in a row. Whoops. Okay, if you subtract 12 from both sides, now we would have negative 4 over here. So we used subtraction again. Okay. Last step, to get rid of the -2, I would divide. If you divide both sides by -2, you get x equals 2. So to get that, you would have to use division. And there's my proof. Notice I'm ending with exactly what I was supposed to prove. If you kind of did things differently, that's okay. Let's say I had 2 equals x. If I had 2 equals x, that's fine. I would just have one extra step where I flipped it around, and my reason would be symmetric property. But this is fine. So a lot of times, your proof could look completely different than the person next to you, but you guys both have a correct proof. So you guys are going to practice just doing algebraic proofs for now, okay? I don't think this should be too bad. Just use your chart. Make sure you go step by step. Don't skip anything, and give a reason for each step. Later, we are going to do some geometric proofs, okay? And we will be doing proofs kind of all year long. That is all I have for today. I hope you guys have